Everybody, in this video, I'm going to go through our lesson on corresponding parts of congruent polygons. And the first thing I want to do is talk about a super key idea, and that is corresponding parts of congruent polygons are congruent. So if you have two figures and you know they are congruent, the corresponding parts themselves are congruent. And what does that mean? Let's draw an example. And we're going to give ourselves two congruent triangles. So this will be triangle 1. And then to make sure it's congruent, I am literally just going to copy it. But if you're drawing this in your notebook, I would just, try to draw another congruent triangle. So here are my two congruent triangles. So let's label these triangles together. This is A, B, C, and this is X, Y. Oops. Nope, that's right. Z. It's backwards, I know. And to continue with these diagrams even more, A and Z, right? These are the same triangle. So A and Z are congruent. B and Y are congruent. Oops, and X and C are congruent. We also know that this short side is congruent to that short side. This bottom side is congruent to that bottom side. And the longest diagonal side is congruent to the other longest diagonal side. So let's list out all of these corresponding parts. We have corresponding angles and we have corresponding sides. So let's start with the angles first. I'm going to write it out. I don't know why I abbreviated. Corresponding angles. So the corresponding angles here are the angles that are in the same exact position of the shape, and then therefore are congruent if the two shapes themselves are congruent. So we know, for example, that C is congruent to X, right? Those are the same angle in the same position of the triangle. Angle B is in the same position as angle Y, and those two are congruent. So angle B is congruent to angle Y. And lastly, I know that angle A here is congruent to angle Z. Those are all of our corresponding angles. Now let's talk about the corresponding sides. And we want to be careful here. We want to make sure, if I'm talking about, for example, side A, B, I don't want to say necessarily that that's congruent to Y, Z. While yes, that is true. To be the most precise, I would want to say that AB is congruent to ZY because we know A is congruent to Z, right? So the letters in the first position should be the same angles, and then the letters in the second position should be the same angle as well. So AB is congruent to ZY, right? Those sides, are the same measure. We know that BC is congruent to YX, right? BC is congruent to, starting with the angle at the top, that would be YX. That same shortest side is congruent. And then lastly, we know that YZ, or sorry, I don't know why I said Y. XZ is congruent to A. Or I could even say AC is congruent to ZX. This to be underneath our other sides. So corresponding angles are in the same position as each other, just in the different congruent figures, and corresponding sides are in the same position, just in different congruent figures. Altogether, we know these two triangles are congruent. So if I'm going to write a congruent statement for this, I would say triangle ABC is congruent to the angle that is congruent to A is angle Z. So I would say triangle Z, keeping this the same. 1, 2, 3. This should be 1, 2, 3. And B is Y. So angle Z, Y, or triangle Z, Y, C is angle X. So just matching it up here. Triangle ABC is congruent to triangle ZYX, making sure that A matches up with Z, B matches up with Y, and C matches up with X. So how do we get congruent figures if we don't just copy and paste them, if we don't know? They can come from rigid motions. If I transform a shape in some way and it doesn't change size. So a key idea here, this is key idea number 2, really. Rigid motions, and I'm gonna use orange. Are transformations that do not change the size or shape of a figure. And the outcome of this, right, is that it's going to make a congruent shape. So if you know a rigid motion has occurred from one transformation to another, those two shapes are the same. This we're going to use in a moment. So I'm going to move it down here. And we want to talk about what our rigid motions are. We have 3 different types of rigid motions. So the first type of rigid motion is a translation. And a translation takes the same shape and simply shifts it horizontally, which means to the left or to the right, or vertically, or it could do both. So it shifts shapes horizontally and or vertically. So if I have some triangle, this is triangle J, K, L, and I take that shape and I move it over to the right and down. And now it's just the same shape, but moved slightly. Maybe this is called J prime, K prime, and L prime. Those two shapes are congruent, right? I could say the triangle JKL is congruent to triangle J prime, K prime, L prime. Because a rigid motion occurred, there was just a translation. Shifts it left, right, or up or down. Next, we have a reflection. And a reflection flips your polygon or flips your figure across an axis or a line. So again, for the sake of an example, we're going to draw a triangle. This will be triangle. I'll do L, M, N. And if this is reflected, say, across the y-axis, now each of these points is going to be reflected. So N now is going to be over here. M is going to be over here. And L is going to reflect all the way over here. So now we have not too bad. I just kind of need to adjust a little bit. This reflected figure, and it's not perfect, right? My diagram's not amazing, but each of these shapes or each of these points reflects over, which means the entire polygon itself reflects over each point. And so now this is like an N prime, the M prime, and the L prime, these new points. And we could say triangle L, M, N is congruent to triangle L prime, M prime, N prime, because a rigid motion occurred. The other type of rigid motion that we are going to discuss is a rotation. And your rotation really turns your shape around. And it turns your shape around a fixed point. So you're either going counterclockwise or clockwise around some fixed point. So let's say I have, again, let's do an orange, but that's okay. Let's do this will be QRS. And I'm going to rotate this shape. Let me move this again. Each of these points, I'm going to rotate it the same amount. Maybe I'm rotating it around this point here. I'm just going to rotate here. This point will rotate here, and this point will rotate here. So all of these points are rotating the same amount, so the whole shape is turning and rotating around. So it looks something kind of like that. I did kind of a bad job again. It's always hard to say exactly what it's going to be like. But that's not bad. That's really not bad. So this is our new point R, right? This is point R flipped around. The tippity top of the triangle, that was point Q, so that's Q prime. And then this new end over here, that's S prime. So I can say that triangle QRS is congruent to triangle Q prime, R prime, S prime. All right, let's do some examples. And these diagrams are in the OMHS, so please print them out if you can, or else just recreate them. It probably would not take you too long, but either way, you might need to just pause the video to do that. Example 1. Figure 1 and figure 2 are congruent. And here are those figures. Bigger. And we're going to answer just a few questions about this. Question A, which angle corresponds to angle L? So let's look at the diagram. Angle L is right here. So that would be this angle. And we want to figure out which angle corresponds, means in the same position in these congruent figures. And when I look at this, this kind of looks like a kite. It's not really, it kind of looks like a trapezoid, but I don't really know if it is. Either way, I kind of notice I have like this shorter flat side connected to the long diagonal side. So I'm going to try to find those pieces if I can. And they make like this really obtuse angle. Ooh, it's kind of hard to see when looking at the other diagram, right? So you could try to just imagine, okay, which one matches up, or you can try to imagine how I could turn figure 1 into figure 2. And if I needed to transform this first figure into figure 2, it looks like it's been reflected, right, across some line. So which angle then is the new angle L? That would be angle F. And you might be able to see that visually. It's the angle that's kind of farthest away from everybody else, but that would be angle F. So I know then that angle L is congruent to angle F. Part B, which side corresponds to GE? So let's identify GE here. Here is GE. And imagining that this is reflected over that dotted line, it would be the same exact size, just over on the other side, flipped over, and that is side, start with the new G, right? G maps to or becomes I. So I would say that IK is the corresponding side because G corresponds to I and E corresponds to K. So overall, I would say that GE is congruent to IK. All right, next for this same problem and last one for this problem, we're going to write a congruent statement for the quadrilaterals. We know they are congruent. We know all of the vertices. So we can kind of write a more specific congruent statement. So I'm going to start with figure 1. And if we are doing this in alphabetical order to begin with, it looks like I will be the first letter. So figure 1 is congruent to figure 2. We know that. We just need to make sure we match up the vertices correctly. So figure 1 is quadrilateral I, J, K, L, right? Just looking. Oh, I did that backwards. Why is that? I guess it would be I, K, J, L, following it. You want to follow your vertices around in order, clockwise or counterclockwise. So I guess I, K, J, L for figure 1, starting at I, going to K, then J, then L. So if we're going to write a congruent statement for this, we need to match up each of the vertices. So we have 1, 2, 3, 4 of them. Which one matches up with I? I is congruent to G. So in this congruent statement, the first letter I'm going to write is in figure 2, G, and then K. So now we're following it the same direction. Well, not the same direction, but towards K, which is actually E. So I would write G, E, and now I know the direction we're going, right? When I first started naming my first figure, I said I, K, J, L. So if I'm going to say which figure is congruent, I would say GE, oops, HF. GEHF. And if I look at this, I know angle I is congruent to angle G. I know that E is congruent to K. Oops. I know that J is congruent to H. And I know that F is congruent to L. So these two quadrilaterals, IKJL, is congruent to GEHF. All right, this one I am going to move down just a little bit more because that's example 3. Let's do example 2. Triangle DPR can be mapped onto triangle WQC by a reflection. If the measure of angle P equals 39 degrees, and the measure of angle D is 113 degrees, what is the measure of angle C? And this one actually does not come with an image, but we can draw one. So triangle DPR, I can draw any old triangle DPR. DPR. We know that P is 39 degrees and D is 113. I'm going to switch D and R because I want my drawing to kind of be to scale. I don't know. Oop, didn't mean to do that. So this is D, then P, then R. All right. We know that P is 39 degrees and D is 113 degrees. We also know that DPR can be mapped onto WQC by a reflection. So this is reflected in some way, and DPR becomes W, P becomes Q, Q, so this is W, Q, and then R becomes C. So each of these points maps onto the new one. DPR maps to WQC. So now we have this new triangle, which should be congruent to the first. Mine is not to scale. And our goal is to find this measure of angle C. Conveniently, looking at our first triangle, we know everything except for angle R. So let's start by writing that triangle DPR, it's congruent to triangle WQC because this was a rigid motion. So because a rigid motion occurred, we know that they are congruent triangles. So D is congruent to W, P is congruent to Q, and R is congruent to C. So angle C is congruent to angle R. That's some key information that we're going to need. And this is really because these are corresponding angles of congruent figures. They're corresponding parts. Now, super important here, we know all of the angles in DPR except for angle R. So let's figure out what R is. So angle R, or the measure of angle R, is going to be equal to, if I add up angle P and D and I take that away from 180. So 180 degrees minus 113 degrees added to 39. So really I would say 180 minus whatever the measure of angle P is plus the measure of angle D. Measure of angle P is 39 The measure of angle D is 113. So the measure of angle R is 180 degrees minus 39 plus 113, and 39 plus 113 is 152. So we're going to subtract 180 minus 152. Which gives us a degree of measure of 28. So 28 degrees is the measure of angle C, because it is also the measure of angle R, and those two are the same. All right, last example. And this involves that image, but I'm going to write the problem first. Pre-image triangle ABC has been transformed and mapped onto, or just to, I should say, I could say, triangle GHI. Describe the sequence of transformations. So here's our figure, and it says pre-image triangle ABC. That pre-image means this is the OG. This is the original one that has been transformed. So pre-image means before anything happened. How would we transform this to this new triangle GHI? Our goal is to describe the transformations. And one thing I noticed first is that this is flipped. So I'm guessing the first thing we would do, and let's just see what happens, we are going to reflect across the horizontal or the x-axis. So reflect across the x-axis. So let's do that. So A is now going to become a prime across the x-axis. It was at -1, now it's going to be at +1. So that's the point A prime. B, it was at -3, now it'll be up here at +3. Right, we're just reflecting, flipping the heights of these points. And this would be B prime, actually. And then C was at -2, so now it'll be at +2. So now we have A prime, B prime, C prime, which is this triangle. So how do we turn this new A prime, B prime, C prime into GHI? Well, it looks like we're going to have to shift it, right? We're going to have to shift and just take one of these points. How would I move this bottom tip A to become this new point G? Well, it would have to shift to the right. And how many units would we have to translate? Because we're shifting, so this is a translation. We're going to translate right 1, 2, 3, 4, 5 units. So that would move the shape now to where A prime is over here. So this would be a double prime, or maybe, some other letter. And then C would be shifted over here, and B would be shifted over here, right? So this would be just translating it right. Finally, we would have to translate it up as well. And we would go up 1 unit. Yes, you absolutely could have translated it up 1 to the right 5. And that probably would just be one step. Translate it right 5 units, up 1 unit, or up 1 unit, right 5 units. So these are the steps, and because these are all rigid motions, I can say that triangle ABC is congruent to triangle. And let me make sure I get this right. A is congruent to G, right? And B is congruent to H. So GHI. ABC is congruent to GHI because only rigid transformations occur. Thank you for hanging in with this video. I know this topic is a lot. There's a lot of questions that could be asked. Practice, practice, practice. Send me screenshots if you have a problem you're confused with. I'm always here to help.